All right, here we go. This is a review for the final in electricity and magnetism. First question is north and north poles of a magnet. Well, north and north poles of a magnet, they repel each other because opposites attract. You remember? Number two, question number two. A or an blank slows the flow of electrons. Well, things that slow the flow of electrons are resistors. We did that in our FET lab, so resistors. Correct, number two. Let's see if we can get 100%, huh?
Good afternoon, 6th grade teaching for the class with now. Thank you.
All right, question number three. The picture shows
remember to walk safely. Thank you.
The picture is showing two batteries, so it has to be a two battery system, and those happen to be parallel because they're next to each other. So that is batteries in parallel. So no questions down, the answers are parallel series PE, that's nothing, and circuit breaker. So it has to be parallel circuit. Got three in a row. We're doing well. Next question, what is the benefit from using fossil fuels? Well, there's a lot of benefits from using fossil fuels. There's a lot of problems with it too, but let's see, they smell good? Well, they don't smell very good. They produce greenhouse gases. Well, that's a negative. They produce a lot of energy per gram. That's true, and they produce carbon dioxide. Well, that's a negative. So it has to be they produce a lot of energy per gram. Right, we're rolling. Haven't got one wrong yet. Next question. What is the best solution for global warming in the short term? Well, short term means in the near future. So conservation or reduction in usage of energy, well, that's pretty good. Use more solar energy, well, in the short term, that's just not gonna happen. Use more wind power, probably not gonna happen either because of the expense. And use more fossil fuels, well, we don't wanna use more fossil fuels, so conserving energy has to be it. All right, we're ranked number one. Okay, so this is the picture of a magnetic field. And the question is saying a magnetic field is a one-dimensional, two-dimensional, or three-dimensional. Well, it's got all three dimensions in it. It's got height, width, and length. So it has to be three-dimensional. I'm very happy for us too. We're on a roll. We're ranked number one. Okay, so we got batteries end to end, and they're not quite closed. Only one path or in a single row. Well, parallel is multiple pathways. PE circuit, that's a workout. No, we don't want that. Series circuit, that could be it. Or circuit breaker. Well, circuit breaker would be something that would stop the flow of energy, but it has to be series circuit. Got 7 in a row. There we go. Give me a gummy bear. All right, next question. Ranked number one still. Why are turbines so important to producing electricity? Because fans make electricity? Well, they do. Because turbines make electricity? Well, that's true. Because turbines turn kinetic energy into electricity using magnets and copper coils. And then finally, because turbines are loud. Well, they're loud, but because turbines turn kinetic energy into electric energy is true. That's the best answer. The first two were correct, but the third one's a better answer. All right, so up here where you're looking at the lights, okay, anytime you have a light bulb, you have to have one wire connected to the side of the bulb and one connected to the bottom. So this bulb will light is true. That's true, it will. All right, 830 points. Got that right. We're still ranked number one. All right, here we go. Which one of the following energy sources are the cheapest to use? Well, wind power is expensive. Hydroelectric is really expensive. Fossil fuels are relatively inexpensive, and solar power is expensive. So fossil fuels has to be the answer, and that's why we use so many of them, even though they're destroying our environment. 10 in a row. 10 in a row. We're ranked number 1 again. 1 out of 1's pretty good. Okay, if you want to produce a lot more light and you are not concerned about the power usage, which system would you use? Well, I would probably, let's see, batteries in series. Batteries in series would increase the power to a bulb. Bulbs in parallel, nah, we wouldn't want to do that because that won't increase the light. Bulbs in series, batteries in parallel. If you want to produce a lot more light and we're not concerned about it, we're going to have to say bulbs in series. Oh, got that one wrong. So what's the correct answer? Bulbs in parallel. That's right, because bulbs in parallel, like this picture right here, every time you add a bulb, it increases the light output by 1.5 volts. So got one wrong, but I just went too fast. Which system is pictured? Well, that is light bulbs in parallel. Light bulbs in parallel. See, there's more than one path there. Light bulbs in parallel. Gotta pay attention a little bit more. We can't miss any of these. I wrote the test. No, that's a good lesson for you. You gotta go slow. What is a greenhouse a model for? Explaining how adding CO2 to our atmosphere is causing global warming. Well, that's true. Explaining how plants grow better in certain environments. No. Explaining how the sun's energy is converted into thermal energy. Well, that's true, but it's not the best answer. Explaining how a hot atmosphere will kill living organisms. Well, it could be, but the best answer is explaining how adding CO2 to our atmosphere is causing global warming. Boom. All right, better hurry up on that one. There's a lot of reading in that one. Which energy type is a clean energy? Petroleum? No way. That's a mess. It's black, makes a lot of gooey stuff, burns lots of makes acid rain. Coal's the same way. Electricity or wind power? Electricity is a pretty clean energy, but most of the time it's produced by burning fossil fuels. So I'm going to say wind power. All right. Again, a couple good answers, but wind power was the best. A blank or and blank does not allow electrons to flow. But anything that blocks electrons to flow is called a insulator. An insulator. It also, an insulator stops energy from flowing. Like your jacket keeps energy from flowing out of your body and keeps you warm. So I'm saying insulator. A conductor is something that lets things flow through. A wire, again, a wire is going to allow things to flow through. And a resistor is just going to slow the flow of electrons down. So insulator is the correct answer. All right, we're on number 15. Moving forward. Rank number 1. Who is your favorite teacher? Well, this is really a silly question. Horton Hears a Who? No. Egbert? No. Santa Claus? No. It has to be Mr. Scott. Yeah, we got that one right. All right, still ranked number 1, 10,860 points. More than one path or side by side. Well, what kind of system is this? Well, all these light bulbs are not in a row, and they have multiple pathways to the battery. So that means that it has to be parallel. So is there more than one parallel answer? No, there is not. So parallel circuit is true. All right. 17. We only got one wrong out of 17. That's pretty good so far. What's the biggest challenge that we have about switching to cleaner energy sources? Clean energy is cheaper? No, it's not. It's more expensive. Clean energy is more expensive. That's true. That's not that's a challenge, okay? CO2 is causing greenhouse effect. Yeah, see, that's the reason why we want to switch. People don't want to change to clean energy. They do, but it's just so darn expensive. So clean energy is more expensive is the right answer. All right. 7 in a row. We missed that one. Darn it, we went too fast. That's okay. We can still get an 8. If you wanted a light and battery system to last longer, you would set the batteries in what system? Well, there's only 2 types of system. One's parallel and one is series. Parallel allows the electricity to flow at the same rate at 1.5 volts. Series will increase the voltage and decrease the longevity of the battery. So bulbs in parallel has to be the right answer. So batteries in parallel. Excuse me. There's batteries in parallel. Batteries in parallel increases the amount of time that the battery will burn. Okay, this is the lights in parallel. So if we add more bulbs in parallel to your circuit, the overall amount of light, well, it'll increase because each one of these lights is going to draw 1.5 volts. No, it's going to draw 3 volts because there's 2 batteries up here. So every time we add a light bulb, we're going to add 3 volts of light. So it's going to increase the amount of light. All right. A claim is a one-sentence statement about something you are engineering or testing in science. Well, that's a true statement because we did this the other day, and a claim just basically says it's a statement that says something about an investigation or something that we're engineering that we know is true, and then we will follow it up with information that support that, and data. But a claim is a one-sentence statement about something you're engineering or testing. True. All right, we got 10 in a row. That darn one question, like, still gnawing at me. I know it does the same thing to you. Okay, north and south poles of a magnet. Well, those are opposites, and opposites attract. So there's attract each other, don't like each other. Well, they do like each other. They repel each other. That's the opposite. Are colder than the rest of the world. No, that's true. North and south poles are cold, but we're talking about electricity, and attract each other is the right answer. All right, we're moving on at 22, almost halfway done. If you wanted to produce a steady flow of electricity at 1.5 volts, which system would you use? Batteries in series and bulbs in parallel? No, we don't want to do that because that would increase the system to 3 volts. Batteries in series would increase the voltage. Batteries in parallel or a single battery in series, that's true. Batteries in parallel, no, we don't. That's not by itself. If we had a single bulb, it would also be at 1.5. So the best answer is both those systems would do that. Okay, the picture shows, well, this is batteries end on end, right? So that has to be in series. So batteries in series, or just a simple series circuit. And it looks like there's only one answer with series circuits. So boom, we got that one correct. That was a level 2 question. Pretty easy. All right, we're on number 24. This will go to the midpoint. What shape is the magnetic field? Well, this is easy. We got a circle on the north pole, circle on the south pole. So 2 circles on each pole, 1 on each pole. Square like a magnet? No. 1 circle around the magnet? No, there's 2 circles. Or a rectangle? Nope. It's 2 circles, 1 on each pole. Boom. All right, we're halfway done. I knew we'd get there. It's about time to turn the corner and go home. Here we go. All right, which system is pictured? Well, there's light bulbs, and they're right next to each other in a single row. They got a single pathway, so that's light bulbs in series. So bulbs in series right here. All right, moving on to question 26. More than halfway there. We're still ranked number 1 out of 1. A circuit is a complete circle for electricity. A PE workout? No. A complete path for electricity in a straight line. Well, it's not in a straight line. It goes in a circle. A box with breakers and switches? Nope. Has to be a complete circle of electricity. Now, this question, it has the wrong answer in the system, so I'm going to have to change that one. A circuit is a circular flow of electricity. Which of these energy sources do the least damage to our environment? Well, a couple of people said this and made note of this when we were doing our presentation, that out of all of the fossil fuels, natural gas is the best. We've switched a lot of our electricity production to natural gas. All right, 28. really didn't miss that last question because I had the wrong answer, and I will correct that. Which source of energy is capable of producing the most electricity on Earth? Well, hydroelectric, no, because water is limited. Wind power, no, because wind is limited. All fossil fuels combined. Well, there's a lot of energy in fossil fuels, but the solar energy, the energy that comes from the sun, is probably 100 times as much as we have in all other fuel sources. So solar or sun energy. All right. Still ranked number one, 19,240 points. Which of the following is a renewable source of energy? Solar? Solar's renewable. Coal? No, it's not. Petroleum? No, it's not. Natural gas? No, it's not. All three of these fossil fuels, they're going to run out someday. But the sun, it's going to run out in billions of years. So we're going to take solar for that one. All right, question number 30. We only have 20 left. Here we go. Still ranked number one. Okay. All right, if you add more batteries in parallel to your circuit, the bulb's brightness, well, anytime you add batteries in parallel, the light is going to get the same 1.5 volts, so it's going to stay the same. There's only one answer here that says stay the same. Boom, right there. All right, 20,750 points. Here we go. Electricity is the flow of what? Neutrons, electrons, protons, or water? Well, it's not water. It's got to be a part of the atom, and electrons are in the outer shell, and those are the things that get ripped off from the atoms of copper usually, and makes electricity. So it's electrons. All right, so we're rolling along here. 32, we're on number 32. Which is the best claim for your bulb in parallel, lab? Bulbs in parallel. Bulbs in parallel get brighter. So adding bulbs in parallel is too hard. No, adding bulbs in parallel causes the bulb brightness to decrease. Well, that's not true. Adding bulbs in parallel causes the bulb brightness to increase. That's true. Adding bulbs in parallel causes the bulb brightness to stay the same. Well, it's got to be adding bulbs in parallel causes the bulb brightness to increase. Boom. Oops, that's another one that we have marked wrong. So I'll have to change that one when I go through there, because that is absolutely true. What is the disadvantage of using wind turbine power? Well, wind turbine power is expensive. Okay, they are engineering marvels, that's true, but that's not a disadvantage. They are beautiful to look at, well, they could be. It produces a lot of energy, well, that's a good thing. They are expensive, yes, they are very expensive, so that is a disadvantage. All right, next question. Which system is pictured? Well, there's a bunch of batteries.
Attention to Price Lake Middle School, we're at 7th grade, and down to the gym. Over there, class picture. Again, 7th grade in the gym, class picture. Make sure you're walking and on your absolute best behavior. Thank you.
Which system is pictured? Well, these are all batteries that are side by side next to each other. So it has to be batteries in parallel. So it looks like I have corrections on 2 questions. Nobody told me that they answered that the whole day. Which system is pictured? Well, there's batteries that are going end to end. So this has to be something to do with series. There's batteries in series. That is it. All right. So the key to those questions is you got to see what in the system. There has to be multiple something. If you see something multiple, then find out if it's in parallel or it's in series. All right, which metal is necessary for creating electricity flow? Well, everybody should get this. We've said it 10,000 times. Copper is the magic metal. All right, it says just fabulous. Just fabulous, but I got 2 questions in there that are wrong. A or and blank allows electrons to flow. Well, resistors allow electricity to flow, conductors allow electricity to flow, insulators stop the flow, and a wire allows it to flow, but it's got to be conductor. A conductor is the best thing for electricity to flow, so that's the best answer. All right, we're up to number 38. Got 12 questions to go. All right, south and south poles on a magnet. Well, those are like poles, and like poles repel each other. So we know that repel each other is the correct answer. All right, opposites attract, like poles repel. Which energy source produces the most electricity in the state of Washington? Well, we have a lot of water in the state of Washington. We live on the coast. Most people live on the coast. There's rivers that are running from the mountains to the water. So hydroelectric is our number one producer of electricity in our state. All right, got 10 questions to go. 80% of the way done. Only really got one wrong because we went too fast. Okay, this is a system with 3 batteries end to end. If you add more batteries in series to your circuit, well, the bulb's brightness, you look over here, the bulb's very bright. So if we added another battery, it would just get brighter. It might blow up even. Some of the boys burned out their bulbs the other day when they were doing their 3 batteries in series. Okay, what's the consequence for using hydroelectric power? Well, consequence means bad thing. So it damages the environment around our rivers. Well, it certainly does. It produces carbon dioxide. Well, it doesn't do that. It's easy to build and maintain. Well, no, they are not easy to build. It's very expensive. Well, that's not a benefit. All right, well, I guess it's very expensive as a consequence, but it damages the environment around our rivers. All right, and on that last question, they're really expensive and it damages our rivers, but damaging the rivers is more of a detriment than the cost. Why do we use so many fossil fuels? Well, we're talking about cost again. Because they are cheap, we use them because they're cheap for sure. Because they are easy to transport, they're relatively easy to transport. And because they produce a lot of energy, they do. So it's all of the above. All right. Somebody said to me, if there's ever a question when they say all of the above, you should always answer all of the above. That's not true. Sometimes I throw them questions in there and they're not correct. Well, this is looks like bulbs in a row, so that's in series. If you add more bulbs in series to your circuit, the bulb's brightness, well, you can see these light bulbs are pretty dull. They get more dull when you add more light bulbs in series, and so it decreases the amount of energy going to every bulb because they have to divide that 1.5 volts by 3 instead of 2. Okay, what is the picture? Well, this is a simple circuit. It's really easy. It's got one battery, one light, a couple of wires. So this is a simple circuit. That was a softball. That was an easy question. All right, next question. Only got one really wrong because we went too fast. If hydroelectric power is so cheap, why don't other states use them? Well, if you go to Nevada, they don't even have any rivers there. They have no rivers, or not very many rivers in the mid part of our country. So the answer's got to be that they don't have enough rivers. They don't have any water sources. Hydroelectric is really relatively cheap and provides a lot of energy, but it's really expensive and you have to have the flow of water. Electricity is often called a clean source of energy. Why is that not the case more than 70% of the time? Well, 70% of the time it's produced by burning fossil fuels, so it has to be this one right here. Because electricity is used in machines like cars that produce carbon dioxide, that's not true. So, right here, boom. I can see that we need a little bit more time for you guys than 1 minute. So tomorrow I'm going to set this without a timer. If you wanted to overload a circuit and blow out the light bulbs, you would use, well, a series circuit increases the voltage. And voltage, if you increase it too much, it's going to burn out the bulb, just like we found out the other day. So bulbs in series has to be the answer. Not bulbs in series. Sorry, I hit the wrong button again. I'm going too fast. Not bulbs in series, batteries in series. Okay, so you can see I've got 2 wrong, and because I'm pushing the wrong button because I'm going too fast. So I'm going to have to make sure we have plenty of time when we take this test. All right, which is the best testable question for your bulbs in parallel lab? How do adding bulbs in parallel affect the brightness of the bulb? Well, that sounds good. Okay, why do we have to do this? No. How does adding batteries in series? Well, that's a series question, not parallel. How do adding bulbs in series? Well, there's only one question about parallel, so it has to be there. All right, that was just a process of never mind, let's move on. All right, this bulb will light. Well, for a light to light, a wire has to touch the bottom and it has to touch the side. There's no wire touching the side. This wire should go in here, touch the bottom, go up through, go across here, heat the element, go down, and then go out the other side. Well, this one will not light because there's no wire hooking right there. So, nope. All right, so that is number 49. We have one question left. Oh, maybe we're done. So game over. So I got 92%, and that was because 2 questions are wrong, and I went too fast on 2 questions. So make sure you take your time and answer the questions. And watch this over again if you want to get another lesson on how to answer those questions. Because the more you watch it, the better you're going to do. I guarantee it. That was a great game. And thank you very much. Talk to you tomorrow.